Hello everyone. So welcome you all to this YouTube videos. So today we are going to discuss about the hydraulic circuits and along with some case study examples. So before I will introduce myself, my name is Dr.R.Sakthivel Murugan. I am here one of the expert of this fluid power. So here I belongs from the Department of Mechanical Engineering. So in this video let us discuss about the usage of hydraulic circuits and its case studies and how these hydraulic circuits benefited in the applications, and let's discuss one by one. So next I am going to move to directly the case study slide. Okay, so let's I explain this. So this is the first case study that we are going to discuss about the usage of this hydraulic circuits. The case study 1 is design of an energy efficient hydraulic regenerative circuits. So you all know, first I explain what is regenerative circuits. So the regenerative circuits is here. If you look at this, the pump is delivering the fluid from this position to this position. Here the fluid is moved to this double acting cylinder. So what happens, the cylinder will get extended in one direction. So at the same time, so here the excess fluid, if you look at this circuit connection, this excess fluid is not directly returned to the reservoir, and here if you look at this area, it is bypassed here. So what happens, the fluid is again sent back to this particular cylinder. So therefore if this side, if you are having the pressure P3 and the flow rate belongs to Q1, that is the flow rate is Q1, and here there is some pressure drop will be there due to some usage of this hydraulic fluid towards some hydraulic components. So here you will get some pressure to assist with some flow rate. So here what happens, the flow rate Q1 should be greater than Q2. So based on these flow rate differences, so here high pressure and high flow rate will be there. So this low flow rate is again injected back to the same flow lines. Based on these flow rate differences and the pressure differences, the cylinder cannot be extended in a fast manner, it should be extended in a slow manner. So this is what the use of regenerative circuits. So this once if this actuated the next wall, here the fluid will be back to this shape, and therefore the return stroke will be in a very fast manner, because while the return stroke this should be sent back to the reservoir. So this is what the use of this regenerative circuits. Okay, so as I explained now about how the regenerative circuits work, and this regenerative circuit is mostly used for making the cylinder while moving in one direction in a very fast manner and the return direction in a very slow manner without the use of any throttle valve. That is what the purpose of regenerative circuit. Based on this regenerative, there is no additional hydraulic or any other components that is needed for making the speed control. So in case you basically if you want to attain the speed control, definitely we need a throttle valve or flow control valve, but here we never had any throttle or back rotor valve. That's why we have reduced the cost of this entire setup. Based on this fluid power difference, that is fluid flow rate differences, we achieved this speed of the cylinder in a fast and slow manner. Okay, this is what the use of regenerative circuits. So what Mr. Ramesh et al in the year of 2018 has done and research based on this regenerative circuit, and they have compared the same operations with another ordinary circuits, and they have made some inferences. So these are the circuit connections used by Ramesh et al in the year of 2018, and with the reference from the Journal of Material Science and Engineering, and the reference DOI is also given. In case if you are having any doubt, you can go to that particular research articles. So this is the setups. This is the setup that Ramesh et al has been done. So this is the cylinder, and here the circuit is fluid back to like this types of regenerations has been made in the laboratory scale setup, and the research studies has been made, and here have plotted the comparisons of two. One is the flow control is compared with the expansion, that is extension time, and then the flow control valve is again compared to the velocity of the piston. So both the extension time and the velocity both has been measured, and they have compared it with some ordinary basic hydraulic circuits. It is observed that so basic hydraulic circuits and regenerative circuits, by using this circuit connections, it is noted that by implementing this regenerative circuits, the overall efficiency of this entire circuit is increased by 5.3%. So this is what based on the research and the case studies based on the laboratory scale research, it is proven that while using this regenerative circuit, the entire overall efficiency of the entire circuit is improved by 5.3% with reduced cycle time and also reduced energy consumption. So here if you look at that, in both the scales, the energy that is the extension time is reduced, and also here the flow and the velocity has been increased, and it indicates the energy consumption is less while applying this regenerative circuits. If you used this throttling valve or some other flow control valve, definitely high energy requirements may be needed. So the in energy point of view, that is energy usage point of view, the regenerative circuits will make the entire circuit will work operated in a very effective manner in very less energy along with some reduced cycle time. So and make the overall efficiency by 5.3%. This is what the summary of the results achieved by S. Ramesh et al. In the year of 2018 based on this regenerative circuits. And another additional focus is throttleless, that is a throttleless single rod hydraulic cylinder positioning system. So if you look at that, so here this is what the circuits they have made. So here load is there, the load is raised up and down by using a roller, using it is known as hoist setup. So one hoist setup is there. If the cylinder is extended through this pulley, the hoist will make the load to move up and down. So what this throttleless single acting rod cylinder positioning system, based on this particular proposed circuit, what is the objective of this one is, so the purpose is to design a low cost effective and a simple hydraulic circuits that does not use throttling valve for making the smoother operations, because while for operating the speed control definitely we need a throttling valve. So without a throttling valve, if you want to actuate any loading systems in a very smooth operation without the use of throttling valve is quite challenging task. So Jalayari et al. In the year of 2015 has proposed this particular circuits, and they have demonstrated this particular circuits in the laboratory environment. So they have made the entire circuits like this. So to achieve based on this circuits, what they achieve is some good positional accuracy. So without this particular circuits, the position of this hoist, the position of this particular load due to through this hoist is not in a very accurate manner. So based on this particular proposed systems, the accuracy and the positioning of this particular load on particular instances is made more accurate. That is what the proposal submitted by Jalayari in the year of 2018. And this is what the proposed circuits, and they are entirely demonstrated this particular circuits through a hydraulic cylinder and some other circuit operations in a laboratory setups. So here if you look at this, the entire laboratory scale, and this is what the load applications, and this is hoist, and this is the cylinder applications. So based on this, here what they have designed is they have used this counterbalance valve. So this valve is known as counterbalance valve. So based on the application of this counterbalance valve, they have make the positioning of this entire setup in a very accurate manner. So without the need of any throttling valve, they have achieved this positional accuracy, and with the use of this counterbalance valve. So these are the pressure transducers which is used for measuring the positional locations coordinates data capture, and these are the pressure relief valve which is used as a safety systems for making operation of this entire setup. So just with the pressure relief valve circuits, the safety is enhanced, and some other pressure sensors and transducers is used for collecting the data just to measure the positional accuracy. And based on this, these are the results and conclusions made by Jalayari in the year of 2015. The first one is used on this proposed circuits, they achieved the positional accuracy. That is, based on this, the error of possible holding of the entire load from one position to one position is reduced with plus or minus 0.03 mm. So the deviation is only in very micrometer level. So therefore the positional accuracy has been improved so much based on this simple proposed circuits by Jalayeri in the year of 2015, and the dynamic performance. So the rising time, settling time were measured periodically using some pressure transducers, and the repeatability was good across so many cycles because the experimental has been conducted for various cycles for various times. So based on the various response times, various cycles, and with varying conditions, the dynamic response calculations and the dynamic response performance is also quite good based on this proposed circuit. And then with the effect of this counterbalance valve, because one of the main component used in the circuit is counterbalance valve. So with the use of this counterbalance valve, the load was held without any continuous pump effort. So basically the pump has been delivered fluid throughout the entire cycles in a 24/7 one. So it is a continuous one, but based on this counterbalance, it not be a continuous support one. So based on this, better control has been get by using to just assist the motion of the load, which is up, lowering down, and lowering, raising up. So these are the effect of this counterbalance valve, and using this counterbalance valve here. So in this state, the power consumption is reduced with the use of this counterbalance valve, because it will not make the entire pump to be operated in a long run. So therefore the running of the pump efficiency has been reduced. Therefore the power consumption is less using these types of counterbalance valve, and therefore we can achieve high energy efficiency. So without the throttleless circuits, the overall efficiency has been improved by 60%. So based on this proposed simple setup, the entire circuit overall efficiency, the entire overall efficiency is increased by 60%, and this proposed circuit alone consumes only 25% of energy. That is, which is compared to an ordinary valve control unit. If we are not using the counterbalance valve or this proposed circuit, so we have the possible to have more than 20% of the power consumption, that is energy consumptions. With the use of this single counterbalance and this particular circuits, 21% of energy is reduced by applying this particular concept. So the overall efficiency is improved by 60%, and while applying this particular setup, the 21% of energy efficiency has been reduced, which is compared with an ordinary supply, ordinary circuit connection of this raising up and down of load using this hoist. This is what the case studies and the inferences suggested by Jalayeri in the year of 2015. So that's why in this videos we have discussed about the two case studies, because mostly in the hydraulic circuits we have easily known about these are the usages of, these are the applications, advantages, limitations of the hydraulic circuit, they are already raised. And for validating that hydraulic circuits, then these types of case studies will be quite useful for measuring the efficiency and the output deliverables of this particular hydraulic circuit used in a separate setup. So two case studies has been discussed. One is the usage of Ramesh et al. In the year of 2017, they have used regenerative circuits for the quiet circuits, and they have compared the usage of the regenerative circuit with the traditional ordinary circuits. And then the Jalayeri in the year of 2015 using this counterbalance valve without the use of throttle valve. So they have studied the entire setup in a laboratory environment, and they have made this entire, they have made the circuit is working in a very successful manner, and they have compared the results. So these are the positive results, and here the overall efficiency is improved by 60%, and the 21% of energy consumption is reduced by applying the simple counterbalance valve setup. And based on these two cases, it is clearly identified that the hydraulic circuits with proper connections will make the industrial automation solutions in a quite improved one. So based on this, with a proper connection of this hydraulic circuits, the industrial automation process has been enhanced by using the energy efficiency, and the overall efficiency has been improved with proper hydraulic circuit connections, and based on that it promotes industry 4.0 for better productivity. So thank you all.